members and your project title.
Yes, my name is Ryan Bauman. I'm an electrical engineering student, soon to be graduating. Brendan Peck, also an electrical engineering student, is our team leader for this project. And then Noemi Mitchell is a computer engineer. Hannah Nguyen is a TE, telecommunications engineer, and Adrian Green is another electrical engineer. Oh, the project title, it was a trailing wire assembly monitoring solution. Really different local calls.
Very good, thank you. Can you just tell us a quick summary about what your project is?
Our project was to create a standalone system that was designed to give a user the ability to observe several portions of the ship or electronics connected to it, various aircraft. So it was modular as much as it could be placed on different aircraft.
Can you tell us about each team member's contributions to the project?
Yes, Brendan, who was our team leader, was responsible for the optronics. He did all the research and looked at the various companies and the components that were categorized and qualified for use on military aircraft and commercial aircraft in general. Hannah Nguyen went ahead and did some of our video presentations and she got some of our test data on the finished project. Noemi was contributed to our original one of our design proposals that we did for our principal design review. Even though we only took one path, everyone contributed to different solutions and looked for different possible answers to the project, the challenge that was given to us. Adrian did another one that was not the final option, but it was a well-researched option. We just didn't work over it. I didn't really go over what I did.
And what was your contribution?
I actually worked with the monitors. I dealt with vendors and discussed some of the non-recurring engineering that ended up being implemented in the final custom.
Thank you. Please show us your working prototype and how it works.
So here, on display today, we really just have the display solution, or the display portion of it, which is where a user would use this, basically a variant of this monitor with different internals provided by Z Microsystems, to go ahead and gain a perspective or gain observance of several parts of military aircraft, one of which being a probe that provides lift through aerodynamics to a trailing wire assembly on various military aircraft, and it multiplexes all of these signals in and it displays them on the same screen. Besides being ruggedized and being categorized with all of the different requirements that you have for EMI, RFI, etc., and power for use on military or commercial aircraft, Z Microsystems actually provided a proprietary technology that they have that does hardware-based video processing. And this was a really good benefit to the project because it gave value added to something that would be used in various lighting conditions and different environments. So this is what you see here, it's just the monitor portion. And the video feed that you see on it is some of our tests that we ran, with the left half of the screen being the untreated, essentially or unprocessed video image, and the right hand being the processed image. If you see artifacting or anything like that, that's a part of the algorithm. But for normal lighting, you see an enhancement. Where it really shines is in things like low light or when there's obfuscation of some kind, say for instance, water vapor, smoke, that sort of thing. And there's a video that they have that's on their website, it's on YouTube. It's really, really good. And it ended up being a great solution for the project.
Excellent. Is there something like this out in the market?
So because this project in particular was done for a defense contract, so no, this isn't really something that's out for an open public market. But and actually, this system is I guess it's a singular design. It's replacing a design, but this type of implementation has not been done. So it's a unique approach in that regard.
How is this prototype different from the UTDesign 1 phase?
So in UTDesign 1, we met with Rockwell Collins, our mentors there, to go ahead and basically get what's called a system requirements review done, where we worked with Rockwell Collins to make sure that we fully understood the requirements of our project, limitations, constraints, things like that, power budgets, space limitations, etc. Then we went through a principal design review after we'd done research, where we approached them with different solutions that we had, incorporating different technologies together in an integrated fashion for this project. In UTDesign 2, our second semester of senior design, we had already passed through the critical design review. We had chosen our parts, we negotiated all the custom engineering work that had to be done, and the finished package/prototype was put together and tested, and the data was taken and presented to our corporate sponsors.
Okay, so Rockwell Collins is a corporate sponsor. How soon will your project hit their market or be in use?
Because of the nature of it, I'm not quite sure what I could say, and I think I'd be speculating really if I gave out a hard date or time. I just know that we're all really, really proud to work with Rockwell Collins on this, and especially on a project that benefits the military. So, although I don't know when they would implement it, or if they already have, or when. Again, like I said, it was really exciting just to work on it and contribute.
Thank you very much.
Thank you.